Hi, welcome back. I wanted to do a quick video about how to plot polar coordinates in Desmos. Desmos is a great calculator online. And normally, if you were to put uh, something like x squared in here, it would know that you wanted to plot y as a function of x squared. Um, if we put theta squared in here, it doesn't know that we want to do a polar plot of r is equal to theta squared. So instead, you have to actually put in r is equal to theta squared, and then it will plot your function for all the theta that you asked it to plot. And here we see that theta squared is an interesting, ever expanding spiral. So you should play around with that. So let's go to the two examples that we had in our recent videos. We have r is equal to cosine of theta, or r is equal to 8 cosine theta. All right, if we look at this function, we see that is indeed a circle that's centered at 4, 0. We also have the equation r is equal to sine of theta, and that gives us this circle here, centered at 1/2, 0. Then we had equations like r is equal to 6 cosecant of theta. All right, and what's that? That was our line. That was our horizontal line. R is equal to 4 secant of theta. That's this. If we write r is equal to 5, circle, yay circle. And now let's talk about the more complex equations that we did this time. So we had something like r is equal to 1 plus cosine of theta. All right, and we see here that there's a domain here given automatically by Desmos. And in this example, it gave us the domain from 0 to 2 pi. And that's what we needed to come back all the way to see this function come all the way back to its center. Let's see what it does when I ask for r is equal to cosine of the 4 pi over 3. Is that the question that I have here? Cosine of 4 theta, 4 theta over 3. And here you can see our theta value, it knew that we had to go up to 6 pi. Let's see what happens if instead we only go up to 2 pi. So if we go from 0 to 2 pi, then our function starts here, and it spirals around until we get to theta is equal to 2 pi, in which case the function value is negative. And you can see that being here, the curve doesn't feel complete because the function value at theta is 2 pi is not equal to the function value when theta is equal to 0. So in order to fix this, we needed to increase this, this value. And if I put a constant in here, let's see if they'll let me put a constant d4. Let me see if they'll let me put a constant in here. Let me call it c. Y equals c. Y equals a. Normally, it will allow me to do, oh, there we go, add a slider, a. So now I'm going to put a slider in here, and as I change a, let me get rid of this, as I change a, this then spirals out and shows you all the different values of how this function increases. Here's theta is 0, going up to theta is equal to pi, or theta is equal to pi over 2. and then this is where we get to when we get to 2 pi. So now instead we need to let this angle go up to 6 pi, and then it does show the whole curve. All right, so Desmos knew what the period was, and not just the period of this function, but this least common multiple of the period and 2 pi. And so now let's go and see how Mathematica does this. How about the next video? All right, stopping.